Okay, so today we're going to talk about another method that is very helpful because we can't use the disk method in every case. For example, there are a lot of solids that have holes in them, that have cavities. For example, when you do oil unions and you're creating pipes out of iron, like I used to. When I was working my way through school, I worked at a place nearby where one of the CNC machines that I worked on was taking a large cylindrical bar of iron and drilling a hole right through the center of it. Okay, so those types of solids you can't get, and it spins, right? So you've got this thing that's spinning and it's going through and making a hole through the center of it. So some solids of revolution are going to have cavities or holes, and so how do we find those volumes, right? If you want the volume, maybe I'll get to one of those, but I'm trying to think of an example where, here, I'm going to, so if you have something like this, and let's say you have a container that does something like this, right? And you want to find out, hey, what volume of water will that hold? Well, how are you going to estimate the volume with this cavity here? We can do that using calculus. Okay, so again, we'll get to more stuff like this. But let's start with just some simple things. What about this example? So here's the region I wanted to rotate. So here's R. So now R is bounded not by the x-axis, but now it's bounded by x equals 1. Oops, not 0. It's not x. Y equals 1. So it's bounded by y equals 1. And it's bounded above by y equals the square root of x. And so now I want to take this region and I want to rotate it and form a solid of revolution around this. So I'm going to get something that is going to be like a cup shaped, but it has a hole through it. So it's going to be a solid with this hole through it, where the sides kind of do this. So it's going to look something maybe like this. And it's going to go all the way around, right? So it's going to look something like that, I guess. Okay? So how do we find that value? Well, this is where the washer method comes in. So here's what we're going to do. Think of it this way. Normally, we would just form our rectangle, right? If we were using the disk method, right, we would just form our rectangle, and this would be our delta x, and then the height of the rectangle would be our f of x, right? And then we would use the formula for a circle, the area of a circle, pi f of x squared, right? And then do the integration from 0, or excuse me, from 1 to 4 in this case. Okay? But that's going to give us this as well. We don't want this. We want to cut this one out. So what if I find the area of this smaller circle? What if I do this? What if I find the area of that circle? Right? So if I find the area of the larger one, right? So if I rotate this rectangle around, I get something like this, right? Where the center is the x-axis. And then if I rotate the smaller one around, I get something that looks like that, right? And so if I take the area of this circle, right, and I subtract out the area of this circle, I'll get the area of the rest, which looks like a washer. And if I integrate this area over the interval, won't that give me my answer? Yes, it will. That's the washer method. So the only thing we're going to do is our formula is going to change because we're going to do the larger circle area minus the smaller circle area, and that's it. So what we end up getting is this. So the volume is going to go from A to B, right, on a closed interval from A to B, and we're going to take the area of the larger square, which is based on f of x, and minus the area of the smaller circle. Did I say square? The smaller circle, which is going to be based on y equals 1, right? Or how do we want to do this? Let's call this g of x. Yeah, let's call this g of x. So f of x and g of x. So then we got g of x squared dx. So in other words, what this becomes really is just pi times the difference of the squares, right? So it's going to be, let me do it this way, because we can factor out the pi, and this becomes f of x quantity squared. Let me write this better. Right? So, but either one will work. Okay, so that is the washer method. Let's do some examples.